So I'm wondering if you checked the determinant on this matrix as we discussed. Remember that the determinant of matrix A is supposed to be 1. If it's not, you didn't do it right. You made some sort of mistake along the way. And the determinant of this matrix A that we did together was 169. It was not 1. And the reason why is because there was a mistake someplace. Did you notice the mistake? So the mistake was, let's go with purple here, was right here. Because this was supposed to be 2 times row 2, and 2 times 2 is a 4, not 8. Okay, so now whenever I add row 2 to row 1, then I should get a 5 in this position, and then everything else should check out fine. Okay, so now let's use that new matrix to encode our secret message. So let's write this matrix down again. So our matrix A is 5, like I'm going to remember this, 22, negative 55. And the rest of it, 2, 9, negative 22. And negative 3, negative 12, 34. Okay, and so now you have to come up with, say, your secret message. So, I'm going to go with my name, Jerome, and then I'm going to go with a space, and then star, and then wars. Okay, and then I'm going to use the table back over here on this page in order to put numbers to each one of those letters. So let me pause right now and go ahead and do that. Alright, so I have translated all my letters into numbers, and now I've got to make them into vectors. So if I am using the instructions, then I would just create a vector matrix of just the first 3 terms, which is 10, 5, and 18. So then I would use my calculator to multiply those things out to get my new encoded numbers. And that encodes as negative 830, negative 331, and 522. Alright, and the nice thing about this is that those numbers, of course, have absolutely nothing to do with the original numbers. And as a matter of fact, the next time I go to encode, say, the letter E, I'm going to get an entirely different number here. So it's very hard to work backwards and decode this unless I know matrix A. Okay, now that I did explain how to do that, like one matrix at a time or one vector at a time. You can do this all at one go. If you multiply your 3 by 3 encoding matrix, whoops, by all of the vectors all at the same time. So I'm just going to go with columns of 3 until I've exhausted all my numbers, and then add any zeros at the end for any blank spaces. So I got a 10, a 5, and 18, and then the next column 15, 13, and 5, and then 0, 19, 20, 1, 18, 0, 23, 1, 18, 19, and I have 2 spaces left over, so throw in some zeros. Now, I can do this all at the same time because this is a 3 by 3 multiplied by a 3 by 1, 2, 3, 4, 5, 6. So my answer will be a 3 by 6 matrix, and it'll be all of my secret message in the encoded numbers. So give that a try with making a new matrix A, and what you are supposed to do is encode your name and your favorite book for the retake.